Welcome to the beginner video series for the GRE. In this video, we are discussing the chapter Geometry. This is the third part of the triangle series that has been going on. If you have not watched the first two parts, please go through it before continuing with this video. In this video, we will be discussing about the concept of similarity. There are two ways to prove similarity in a triangle that we have to know. One is side angle side, SAS. Another one is angle angle angle. We will first discuss about side angle side property. Here we have two triangles, ADE and ABC, the smaller triangle and the larger triangle. Let's take AD as 1 and AB as 3, and let's assume AE is 1 and AC is 3. Here the ratio of sides AD upon AB is same as AE upon AC, which is equal to 1 by 3. So your two pairs of sides have the same ratio. The ratio of sides of the smaller triangle to larger triangle, smaller triangle upon larger triangle. Two pairs of sides have the same ratio, and the angle between those two pairs of sides is the same. Hence the triangles are similar by side angle side. For two triangles to be similar by side angle side, two sides should have the same ratio, or two pairs of sides should have the same ratio, and the angle between those two pairs should be equal. In that case, the triangles are similar by side angle side. This pair has the same ratio as this pair, and the angle between those two pairs is the same. Hence the triangles are similar by side angle side. Moving ahead, we will now discuss about angle 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 property. Let's say these are the two triangles ABC and PQR, and this is angle A. Let's take XYZ, X, Y, Z. This is X, Y, Z. All the angles are same in both the triangles, so triangles are similar by angle angle angle. Now even if two angles are same, still the triangles are similar, because if two angles are same, the third is bound to be the same. The third will also be the same. So angle angle is same as angle angle angle. Even if two sides or two angles are same, then also triangles are similar by angle angle or angle angle angle. They both are the same. Now if triangles are similar, the ratio of sides is the same. Now how do you write the ratio of sides? One of the ways is to look at opposite angles. In triangle ABC, opposite to angle X is BC. In PQR, opposite to angle X is QR. So these are the two sides opposite to angle X. This ratio will be equal to the ratio of sides opposite to angle Y, and that ratio will be equal to the ratio of sides opposite to angle Z. Opposite to angle Y in the smaller triangle is AC. Opposite to angle Y here is PQ. Opposite to angle Z in this smaller triangle is AB. In this case it's PR. All these ratios will be the same. Okay. The way you write the ratios is to look at the opposite angles. Now one more property. If triangles are similar, then the ratio of areas is the square of ratio of sides. What do I mean by that? It means ratio of area ABC to area of PQR is the square of ratio of sides. This is the ratio of sides, or this is the ratio of sides, or this is the ratio of sides. So this is equal to BC upon QR whole square. Okay, if triangles are similar, then ratio of areas is the square of ratio of sides. There's one more thing. If triangles are similar, heights are also in the same ratio as the sides. If this is h1 and this is h2, h1 and h2 will be in the same ratio as the sides. So again, let me reiterate everything. The two triangles are similar if all the angles are same, and we call it angle property. Even if two angles are same, then also triangles are similar because third angle is bound to be the same. So angle is same as angle. If two triangles are similar, they have the same ratio of sides. How do you write the ratio of sides? You look at the opposite angles. Opposite to angle x in the smaller triangle upon opposite to angle x in the larger triangle will be equal to the ratio of sides opposite to angle y will be equal to the ratio of sides opposite to angle z. And ratio of heights is the same as ratio of sides. And also, if triangles are similar, ratio of areas is square the ratio of sides. I hope this is clear. We are going to move ahead. Now I want you to solve this question by pausing the screen. I hope you have done so. Now let's solve it together. We are given AD is 1 by 3 AB. We can also write this as AD upon AB as 1 by 3. And also we get AE upon AC as 1 by 3. So this upon this is 1 by 3, 1 by 3. So your two pairs of sides have the same ratio and the angle between those two pairs is the same. So your triangles are similar by side, angle, side. Two pairs have the same ratio and angle between those two pairs is the same. So side, angle, side is the property through which we can prove the similarity here. Now we are asked to find the ratio of area of ABC to the area of quadrilateral DECB. Okay, ratio of this smaller triangle upon the ratio of this quadrilateral. Now we know if the triangles are similar, ratio of areas is square of ratio of sides. So area of ADE upon area of ABC will be equal to square of the ratio of sides. Ratio of sides we know is 1 by 3. So ratio of areas is 1 by 9. So if you take the area of the smaller triangle as x, area of the larger triangle will be 9x. So that means if this is x, this entire thing is 9x. So if the whole thing is 9x and this is x, this must be 8x because x plus 8x must equal 9x. So that gives you that the area of triangle ABC is x, area of quadrilateral DECB is 8x. Hence the ratio is 1 upon 8 and that is our answer. The next concept is the midpoint theorem. Let's say D is the midpoint of the line segment AB and E is the midpoint of this side AC. Now midpoint theorem states that if you join the midpoints of any two sides of a triangle, the side form or the line segment formed would be parallel to the third side and half of the third side. Again, let me reiterate. If you join the midpoints of any two sides of a triangle, the line segment formed would be parallel to the third side and half of the third side. So if D is the midpoint and E is the midpoint, then DE is parallel to BC and DE is also half of BC. Okay. Again, let me reiterate. If you join the midpoints of any two sides of a triangle, the line segment formed is half of the third side and parallel to the third side. With this, we come to the conclusion of this video. See you in the next one. Thank you.